All right, so this is Regents packet number 2. Well, sorry, number 3, starting with question 9. So it says, base your answers to questions 9 through 12 on the diagram below and on your knowledge of earth science. The diagram represents a portion of a stream and the surrounding bedrock. The arrows represent the movement of water molecules by the processes of the water cycle. The water table is indicated by a dashed line. Letter A represents a water cycle process occurring at a specific location. Letter D represents the distance between the water table and the land surface. All right. So number 9, it says identify water cycle process A, which produces cloud droplets. What answer we got for A? Not precipitation. Condensation. All right. Number 10 says, describe the soil permeability, right, and the land surface slope that allow most infiltration of rainwater and the least runoff. So when we're describing the soil permeability, in order to get the most infiltration and the least runoff, what should the permeability be for number 10? The permeability should be high, right? What does permeability mean, first off? Not how much it could stand. Permeability, what is it? The rate at which water enters the ground. So if you have a soil that's high permeability, that means you have the ability to allow a lot of water to pass into the ground. All right? Yes. Yeah, wait, somebody's out. So let's take a look at fact 17 for number 10. 17BI. Let's take a look at 17B and I. All right. So we see permeability is the rate at which water enters the ground, right? And it says the amount of runoff or infiltration is mainly influenced by soil permeability, saturation, and land slope. Land with a gentle slope allows for more infiltration. All right. So that means if we want the most amount of infiltration, your soil permeability must be high and your land slope must be what? Must be flat, right? Or low. All right. One thing to keep in mind, if you want the most amount of infiltration, right, and the least amount of runoff, runoff is the ability for water to stay on top of the surface. So, for example, flood is an example of runoff, right? So we want the circumstances where we get most of the water to infiltrate into the ground. If your land is flat, you're going to get a lot of infiltration. If your land was steep, right, if it was like this, you would get more runoff because when it rains, when it ends up raining, right, the water would, instead of seeping into the ground, it would just flow downhill. All right. So that's the correct answer for number 10. All right, number 11 says, explain why the distance D from the water table to the land surface would decrease after several days of heavy rainfall. What is the water table again? Looking at the diagram, what would be the water table? Well, what does this saturated zone mean? When you see the word saturated, what does that mean? Wet. It also means what? Not Not so much moist, saturated. Doesn't saturated mean fill, like filled up? So the saturated zone tells us right here that within this bedrock, this entire area is also filled to capacity with water, right? The water table is that limit, is that boundary line where now you're touching soil or bedrock that's filled with water. So they're saying as more heavy rainfall occurs, why would distance D be smaller? Why would distance D be smaller now? This originally is what distance D would be. Why would D now be this high? What would be the reason? Well, if we had more rainfall, what would that happen to the water table if more rainfall occurred? The water table would rise, right? If more rain was coming into the ground, wouldn't that mean that the water table would end up rising? Right? Because now there's even more water that's inside the ground. So the reason for that would be is that because more water infiltrates the soil, the water table would increase. The water table would increase. That will be done. So number 12, it says how many joules of heat energy are required to evaporate 2 grams of water from the stream surface? What page of the reference tables would I refer to for this question? Well, let's take a look. Let's go to page 1. Right? And we look at properties of water. Vaporization and evaporation is the same thing. So they're telling us this is the amount of energy, right, gained for only 1 gram of water. So what would I have to do to find out for 2 grams? What would I have to do? I would have to multiply by 2. So therefore, it would be 2,600 times 2, and you would end up getting 4,520 joules. All right. For the other questions, you could click on the next video. Make sure to like, share, and subscribe.